Hello! Well, in this episode of correct machining, it will be another motor coupling. This time it will be a very large diesel between a very large diesel engine and a very large electric generator. So, and yeah, it's not 10 kilowatts, I think it's more like 100 kilowatt generator. So the coupling is definitely larger than this one. This is like a micro coupler if you compare to that. Wait a minute. So here we go. This is the coupler, and well, made in Germany. Wow. So what we are going to do? We have a shaft which was originally part of the diesel engine, and this has to be cut off. And then we need to make a flange where not this. There is another piece which is sitting there. So yeah, that's it. But we need to weld probably the flange to the shaft. So it must be straight, and it has to be, well, 100 kilowatts. Yeah, okay. Means it has to be a very, very good weld. Well, let's do that. So, here is the material for this flange. And wait a minute, what's the diameter? I don't know it exactly. Well, whether we need to know it exactly, that's a different thing. But just for my curiosity, well, it's 180 millimeters in diameter. Seems about that much. And well, this is really rough, the outside. So I didn't dial this in, but I centered it by the insert, so that when it was scratching, I moved it a little bit, started scratching again, I moved it furthermore, and now it's scratching a little bit all over the place. It's not exactly, well, it's as well in the center as it might be in there. Another thing is that what we are going to do here now is to face this. And yeah, we have to have the lathe on. So we are going to face this, and there is a lot of crap all around there. And therefore I have all these shields here. I have also a paper towel here under, so that it doesn't collect this stuff into places I cannot clean it out from. So now it should, you are not fortunate enough to see the insert and how it cuts. Let's see what is the situation here in the, well, speed-wise this is okay. It's well, it's a little bit yeah, okay. At this point it's okay. So let's see which direction it is feeding. Wrong way. Now it's feeding the correct way. And then I need to touch here. And this will be a little bit yeah, okay. Yep. And now what I shall do, one error, one failure in this case would be to peel off very tiny amount of stuff from here. You have to cut deep enough to go under this rough surface. So I can dial in not with this one but that one. What would it be? Half a millimeter is quite a lot actually. So let's try first 0.25 millimeters. That might be it. And I'm feeding this, well, 0.076 millimeters per revolution. And as I said, I'm running it 120 revolutions per minute. Or did I say? I don't know. But that's how we do it. I will first face this, and after that I collect shit all over what it produces, and we shall see whether we need to beautify it even more. So let's start with this one. Wow. So far it looks actually quite good. Let's take these things away. Oh yeah, you have some rust dust there. I think I don't need this anymore for this surface, but let's see now. And I run it dry because I didn't want to create a mess here. And I also try to wipe the vase as clean as possible. And now, in order to not to create a mess, so what I can see here is that we need to take a little bit more. We have something like that there. Not too bad though. Okay, because I want this surface to be really good. And as you could see, the hole is not concentric. That's not a problem. The outside is now the important one, so that we get the maximum diameter we can get from this workpiece. So now what I will do, I will actually pull the blade a little bit away from there before retracting this, because I don't want to. If you scratch the surface with the insert like that when dragging, usually it will crack your insert. Oh, well, yeah. So, and well, I let those. I will take these also away. These are the paper, the towel here. Let's now see if I can get it from there without pain. These magnets are really powerful. So, okay. Oh man. Now I have. Well. Oh man. Oh yeah. Okay. But I did succeed in having this rust in the paper, not in the lathe. It's now in the paper and now it's in the bin. So, yeah, nothing much here. It's quite clean actually. Good. Okay, so now I will peel another layer, and you probably noticed that okay, and this one also has some yeah. So you probably noticed that there was I increased the speed towards the center. Yeah, that's that you have to do that. So now I start again with a very low speed. Oh, there you are. And then the VFD also in the very low value. Let's see now. Yeah, there you are. And then I will take another 0.25 millimeters here. Let's see. I'll try this first here so that it really, well, yeah. Yep, okay. There we go. Once this engages this, there you go. Now we go. Yeah. One more thing, let's check out. Okay, so it's 0.25 millimeters, and I will repeat the thing. So, yeah. So now this is now reasonably flat, and I think okay, I will now pull this away from here, and we didn't well, the material, by the way, this is some mystery material. I really don't know what this is. It's not cast iron, I'm sure of that. I believe this is cast steel, because it behaves, it crumbles, but it doesn't make the mess as cast iron makes. So low carbon cast iron. Oh yeah. So, and the surface finish is now okay. It's adequate for the for this purpose. Next, I will bore this hole. There you are. Is it already long enough? Yes, it is. And the insert is adequate for this one. Well, the tool is wrong way around in the holder. Well, but that's not a problem at all. We can fix that. And yeah, it's very important at times to clean up these. Really, not to leave them with a lot of burr and a lot of chips on them. And also this holder, because well, yeah, chips in between there are not a very good thing. So now you can see how it is the wrong way around. So yeah, lucky me, this isn't a real problem. I just need to put it the other way around there. About that much, I believe. I'm checking the stick out here. Yeah, it's okay. Because, yeah, and now I need to take care of the travel. This is something, okay. So this actually determines the stick out. Not, yeah, as you can see, I cannot, it touches there. So I need to take it that much back, put my carriage stop there. I don't want to have a collision with that one. Let's see if this is now. Okay, we can, I think we can. Yeah, okay, so there you I can take this a little bit. So I'm adjusting my carriage stop so that I don't need to take care of the clearances here. It's so easy to run your lathe into something. And then, since I'm now here, I can actually adjust this stick out now quite well. Yeah, you optimize it in a way that you don't have too much. You have just what is needed and that's it. No more. And yeah, this probably will ruin my insert because it's such rough surface inside there. Let's see now. Let's pull this back. I don't need the live center here. Why is it here? Yeah. There you are. Okay. Okay. That's about the minimum. Haha. You know what? It's already like. Now it touches this surface. Man, that's. Okay. I really need to take care of these things so that That's too much. I leave a few millimeters here, or like 5 or maybe 10. Enough anyway. That's it. And now, because I have to move it, I need to move it again this way. Let's tighten this. Look here back that it comes out like that. There you are. Now we are ready to go. And now the speed. How fast should I run this? Well, actually quite fast. And well, I would really like to run it something like 1000 revolutions per minute, 800 or something like that, but it's a massive thing. So we have to settle with 500, maybe 600. Let's see. Yeah, this is what we have to deal with. And then we are feeling that way, and the direction, of course it's the wrong way. Let's see now, I'll put it inside there and see that we have clearances here as well. Yes, I think we have. Okay. That's the 0 touched. And now I move you into a more suitable position so that you can see something. Okay, yeah. So here is the hole, which is very not concentric at the moment, and I will try to make it concentric. And 50 millimeters in diameter. It's nowhere near 50 millimeters at the moment, but after this operation it will be. So, what else is there? Nothing more, just go on and start boring. Okay, well, this hole here needs to become, well, 50 millimeters in diameter, and well, yeah, at the moment it's already concentric. Oh, wait a minute, I get my, I don't really know what's the diameter at the moment, but soon enough I will know. I expect it's about 4.5, 3.5. Well, it's 35 millimeters. Okay, well, we have 15 millimeters to go, which is not very little. This material seems to be a little bit crunchy. I don't know what this really is. It's, well, something. I needed to change the angle of the insert, how it attaches the surface. It seems to work better now when it's angled like that. Yeah. I'm peeling off 0.5 millimeters at a time, so there will be altogether 30 passes doing this. So let's go. So now we have a hole here, which is about 50 millimeters. Let's see, how about is it? Well, quesometer is accurate enough at this time. It's actually over this, it's about 51. Our target is 52 millimeters. So I will actually I will do the rest with, the target dimension for this one is 52 millimeters. So I will well, take snap gauges, etc. But before that, I would like to clean up this mess. This created, well, yeah, a mess. It's really a mess. This stuff is all over the place, and it's, well, it's not fun, so to say. Yeah, let's see, we have, okay, that's okay. Yeah, but after cleaning up, I will measure it again with snap gauges, and then I probably will also turn my insert. This, well, it has a bad edge. I might also change a totally new type of insert there with a very sharp edge, so that I can get this hole precisely. It feels like the hardness of this material is changing. There are high spots here which this didn't well cut. And well, I have one type of an insert which will cut everything. So I can get this totally smooth. This is not totally smooth. It has high spots here and there. Not very good. So I will clean up, change the insert, and then measure it, and then I will bore this hole to 52 millimeters. Yes, now this hole is now 52 millimeters in diameter, and the surface finish is well, it's really good. You can scratch it with your finger, but well, it's a finish, a very good finish. This material is not very forgiving in how to make this. Okay, but next step, this will be welded to a shaft, and there will be, I will now turn a chamfer here so that I can weld it, so that there will be some penetration into there. And of course the shaft will be chamfered as similarly. I don't want to have any stuff under there when I turn it. I will turn it now to 45 degrees. So, well, Celsius. There. This is nothing exact at this point. So here we are, 45 degrees Celsius. Oh! Okay, there you are. And now we just go, I think, half a millimeter, let's see. Yeah. And now I will do this until we have a decent chamfer there. Wow. Okay. So. Oh. That's enough. I don't want to make it any deeper. One more thing, this is going to be a shrink fit for the shaft. So this welding is there only to, well, it's contributing to the holding. Okay, now we are done with this side. And now I will turn this workpiece around in the jaws, and well, The material I was given has a groove inside of it. It is quite deep and spans all across one side of the disc. I drilled some holes over that groove in order to get better penetration when welding. I'm running this with 160 amps current, which should help with penetration. I'm trying to fill in the drilled holes and the groove in such a way that turning in the lathe will leave a flat surface. Wow. Cool. The weld looks alright, but the final test will be done in the lathe. There we can see whether this cleans out or not. This is now the moment of truth. Does this clean out properly? First I scan for the highest spots and then go on from there. So far so good. Now it is already peeling the surface of the parent metal. After this we will see whether it will clean out. Seems like the weld has warped the disc. The weld looks like it would clean though. This is now make or break. If the weld does not clean, I will just leave it there. There is this tiny spot that did not make it. Also seems like some of the material has hardened. Well, I'm satisfied with this. Well, now I have the workpiece attached, clamped to my milling table. So, yeah, the intention now is to to dial in this workpiece so that the spindle, this milling machine spindle, is exactly in the middle of this hole. Well, that's one. But first I needed to know, because this is the thing, the coupling that will be bolted into this one. And so we have to replicate this 6-hole pattern into that one. Replicate it. And it should be quite accurately there. So how to measure the radius of this pattern, the radius here? That's one. Well, in this case it's really easy, because it's we have 6 holes here. So actually the radius from the centers of these to the center of that big hole here in the middle is exactly the same as the distance between 2 holes here, these two. So the radius, the distance from this center here to this center here is the same as the distance from this center here to that center here. Well, you can check out from geometry books that one. That's one nice thing about hexagonals, that the side is the same as the radius. So, yeah, okay. So how to measure this accurately? Because I don't know what are the diameters of these holes. All I know is that they are round, yeah, and well, they are round. That's actually everything I know about these holes. But there is a way to measure it quite accurately with a quesometer. You could use other type of measuring tools for this one, but quesometer is accurate enough in this case. So, to measure a distance between let's say these 2 holes. Well, first of all, you measure the insides like this. Yeah. And what I get here is 35 millimeters this way. Then you measure the outside of like that. And what I get is 67 millimeters. Okay. So after that I make a note of this. I have here a paper. I will put a better picture for you to see. So there is the paper which I write those, and there is also the average of those. So you sum 35 plus 67, and then you divide this result by 2. And this gives you 51 millimeters. Well, I repeated this process all over here, and I got pretty much the same results all over. Well, and then I did the same thing across the whole thing, like this. First the inside and then the outside. Well, this will give you the diameter of these. And from the paper we can see that there is 79 and 22 millimeters, giving me 50.5 millimeters, and it was all over the place. That was a little bit, what is this? And then, this way of measuring is really nice, because it doesn't first of all, the holes don't need to be the same size. And second, you don't need to know the size of the holes. the diameter of the holes themselves. So, we should get the radius directly from here as well. So if I measure here, I will get, what do I get here? Well, something like the 22 millimeters. And then this way around I get 79. Yeah, so 22.79. And this also gives me, that's funny. Oh, I made a mistake there when I was telling that I was measuring this one. So this is 80. This is 117.5 and this one is 85.5. And this is the one I told you, 22 millimeters. You might also already notice the error I made there. I'm reading the paper actually there. So this is 22 and the larger dimension when I measure it this way would give me 79 millimeters. And I measure it from here and from here and from here and from here. All possible places. So I got it, reasonably well. And they all gave me the same result, which was 50.5 millimeters. So now, it is actually, the diameter is actually 4 inches. Yeah, it's 4 inches. So I made an assumption. This is the distance here, the diameter of this bolt circle is 4 inches. So when I now turn this paper over, I have marked here 4 inches, which is 101.6 millimeters. Yeah. Well, it sort of agrees with my measurements here. So now we should have a diameter of diameter of 4 inches, and the radius is of course 2 inches. So how to determine the bolt circle places here? Well, if you search internet, you will find by looking for example, you can look for bolt circle calculator, and there are multiple places which give you the opportunity to calculate bolt circles and the placing of those. So I did one, and there is a list in the paper about the placing of the holes. Very easy. So I actually, there was an opportunity to place it where is my start angle, and I gave it 30 degrees so that I don't, there is a hollow spot under here. So I don't want to drill a hole through that one. I want the holes to be around that hollow spot. So therefore the first hole probably will be starting, it's starting at Y0, something like here. No, 25.4, 1 inch away from there. It should be somewhere here, probably. Yeah. And then the next one, and so on. So those coordinates are all referring to the center point of this hole here. So now I will simply dial in the center hole. So to dial it in, I have my hammer here, and I will lift up the table now. Lifting it up, up. And there you are. And I eyeball it about, I lock this X a little bit, because this this is so that there is a handle in the there at here we have a handle which has a crank which has a handle, and that handle is heavy enough to turn the wheel so that the table goes. So therefore I lock it a little bit so it doesn't like float. So now I can go with my Y here and I gently touch it, just a little bit, so that I can with my X find the minimum here, about there. And please note, this is not accurate at the moment, not at all. It is accurate for the X direction, I mean Y direction, but not X direction. So X direction cannot be dialed accurately this way, but X, the placing where to measure the X can. And now, what I want to do here is to have my backslash in a way that cranking this way, like clockwise, will be like against the backslash, and counterclockwise, making the coordinates smaller. I have to pass by and come back. Wait a minute. Yeah, so this direction will be like so. I will adjust the backslash in a way that when I go here, now we are like 2 millimeters past the point, but let's go to the zero. Here we are. So now it is so that when I turn the crank clockwise, I don't need to take care of the backslash. Counterclockwise, I need to take care of that. Okay, so that is our diameter 0. Well, let me. So now, so the diameter of this is 52 millimeters. So we need to go 26 millimeters more. So 26 millimeters more. That's 25, and that's 26, like that. And now I mark my Y 0 here. Let me do this one more time because I have to be really sure of this. So past, because I'm turning counterclockwise, I go past the point and then I come back to 0. See that this is in 0 here, it is. And then I go to 26, 25, 26, and that is my Y0. And I put the dial here, there is a scale here under. Put it to some known millimeter. That's okay. Okay, now the Y is zeroed in the middle very accurately, or not very accurate, accurately enough for this. I believe it's inside plus minus 200. And then we do the same thing here. We come back first, and now, well, this is now the X. Go past the 0 like this, and tighten a little bit more because it's drooping, so to say. and go to 0. And then I zero my dial here so that I can measure the 26 millimeters first. And here as well. I'm resetting the dial here in the background. Okay, and now we go. So it was 26. That's 25 and 26. There you are. Well, and zero my dial here. It's important to zero these dials. Also, by the way, I forgot to zero my Y dial. It's very important to do that, otherwise your measurements will be 2 millimeters off. So now we have not reset this scale here. This is also important so that I know the coarse point of this. Okay. Well, there you are. It's now we have the scales zeroed, and we have the dials zeroed in the middle of the hole. So we know where the whole middle of the hole is. Yeah. Okay, then I just get rid of this. The hammer. Let's see if I can. Yes. You have to be very careful not to drop this. It's easy to crack the hammer. And then I need to get rid of that as well. We need to have back gear in order to get this out from there. This was not tight at all. It doesn't need to be. So, sorry. I will be using this ER25 collet system for my drills. And yeah, I'm not going to drill the holes right all the way through. I'm just going to mark the places, and then the actual holes will be drilled in the drill press. It's so much easier there. So, the first hole seems to be, now if we look into the paper, so X should be 43.99. 43.99. So let's go. 43.99. 43.99. 53 actually here. 43. 1, 2, 3, 43. I need to have my optimizer. Starts to be, you can see the zeros very well, but not 43, 42, 42, yes, and 43, 43.99, 80, 90, 98, 99, yeah. Okay, that's X, and then Y, 25.4, so 1 inch actually. 20, that's 10, 25.4, 25, 5 is there, like that, 0.4. Yeah, 0.4. 0.4. Yeah, there is the place for our first hole. And now, so if this is number 1, I'm just going to mark the places now here. Let's see if I can predict where they go. So if this around here is 1, so number 2 will be x will be 0, it will be somewhere here, and it will be 50, okay, it is here under, like that. That's true 2, then this is 3, we should have here number 4, and this should be number 5, and about here should be number 6. Like that. Like that. Yeah, okay. So, this is now the same 4mm drill which I used to mark the places for the 6 holes in this one. Well, we are going to tap this to M16 thread coarse with this, and the tapping drill size is 14mm for this one. So I will first use this drill to make the pilot holes, and after that for each hole I will first drill, and then I will change to the pilot drill and to the tapping size drill, and after that change to the next hole. So let's go. now this is the last hole, finally. It has been, well, especially the tapping of these is really hard job. Okay, so let's drill the last hole. This is the 4mm drill. There you are. Okay. Now I can put this drill away. It has done its job. It's a very good practice to not to have the drills like when you don't need them anymore. You should really clean them and put them away. Otherwise, if you collect this stuff all over here, it's not good. And then, well, I have a dial here in the back, so I can move the table and I can move it back. So now, same applies to this chuck, not needed anymore. So I put it away. And then we have this. Now, the tapping size for M16 would be 14mm. But this is such hard stuff that I changed this to 14.5mm. It's 0.5mm too large, but it's still creating a very, very good thread. This has, let's see now, that's the place. So this has, well, it's, there are threads enough, so to say. And now let's go with this one. So this was 14mm, and of course the speed is not, now it's good. There we go. Last bit of this hole. I don't want to push it through with force. So now here you are, it's done. Yeah. Wow, it's a lot of these, and these chips are really nasty. So I collect them here first, and well. So now, this is also no more needed, this drill. So you are, clean it up like this. It's a very good practice to clean those drills after you don't use them for this time anymore. Of course I will use this drill sometime in the future, but not just now. So then we have a tap follower, which I changed here now. Goes here like that, and then we again place this stable to the. So each revolution on this crank is 5mm, and there is a scale with 0.1mm graduations, and there you are. Okay. Well, I didn't chamfer those in advance. I will chamfer those after I have threaded these. Okay, there you are. And then I push this down a little bit, so that this has an automatic feed. Oh yeah, and we don't need the drill anymore, so I shut it down as well, so it doesn't make noises here. We'll shut down pretty soon. There it went. Some cutting oil here, and now starts the fun part. Fun and fun. Yeah. And this is really like quite hard turning. And because this tab is the normal tab, I mean it's not like spiral flute or it isn't a gun tab, it's a straight tab. It means that it actually will, you need to clear the chips every now and then. Otherwise you will break your tab. Well, it's not very easy to break a tab this size. I'm pretty sure I wouldn't be able to break it with this handle. I need a lot bigger handle to break the tab, I believe. Especially when I have it supported like this and I'm using like equal force, so I don't twist it. Twisting a tab is a sure way of breaking your tab. Oh man, this is, oh, it's the last hole, lucky me. Oh. Oh. I believe this would benefit of a bigger tab wrench, but I don't have a bigger one. We are through quite soon. I think there you are, yes. Finally. Yeah. And now I can lift the tab follower away. There you are. That's it. Oh. And now clean up the tab. This wasn't mine. My neighbor borrowed me this tab to tap these holes. I told him that I don't have a tab of this size. So, okay. I will return this in one piece to him. I warned him that it might break. Sometimes the tabs break. And he said that it's okay. No, it's not okay if it breaks. There you are. There is the tab. And then we don't need the tab follower anymore. So let's take that away. Put it into its storage place. I have places for each and every item here. Okay. And then this one. Let's see. There you go. Slow speed, please. Yeah. Takes the burr away, which is, yeah, good. I might need to run the tab through those. And now we have a horrific burr here. Not anymore. Yeah, it clears the burr. Okay. This material is something really special. So now dialing in this workpiece here, and well, well, I think we are quite near what we can get it. So I will tighten this now equally tight all, so that it doesn't move when we really do the thing here. There you are. allows me to do this okay. Then 0.25 millimeters more. The material is free cutting, I would say. Oh yeah, yeah. I think we can now probably set a center there. Yeah. So now this portion here should become it's about the length is 25 millimeters and the diameter should become 52 millimeters, quite exactly. The hole which I bored is 1/100th of a millimeter smaller than 52 millimeters. So it will be 1/100th of a millimeter shrink fit. Not a lot, but this ensures that the workpiece, the thing we put here stays straight even when I weld it. So let's go. Well, I'm feeding really slowly this one, and I'm peeling only 0.25 millimeters from diameter. Yes, and since we don't have a lot of material in this case, we have less than 1 millimeter to go, so I will measure it. There we have a good surface. There you are, I think it's 53.05 millimeters, I believe. There. So after this cut, it should be 52.75. Let's see. And by the way, the surface finish is really nice. Let's see now. So, 52.75, yeah, okay. This is not easy to measure in a way, okay. Let's look it there. So this is the measure now. It's not 75, it's something else. It's actually, well, 77. 77, and now after this cut it should be 52.5 millimeters. My intention is to cut really the last cut even be 0.25 millimeters. Okay. Well, the surface finish is still good. I test it every time, but yeah, okay. Okay, but let's see that we don't have any chips there in between. That would be bad. Okay. So, okay. Now we are there. Now I just trust my dials from here from now on. It's really like exactly what it should be. And this is not warm, so well, it's lukewarm warm, but not like hot. Nothing that would impact the dimension. So we have half a millimeter to go. So let's take next 0.25 millimeters here. There we go. Okay. Now I measure it. Okay, I test the surface finish. It's good. Oh man, I cannot resist. Well, it's very nice to touch when it's smooth, and when it's not smooth, it's not so nice. Okay, that should be it. And now we should have like 52.25. Yeah, that it is. And well, this is now the last pass. Last 0.25 millimeters, and there you go. Yep. Well, it should be there. Let's check it. Oh yeah, oh man. Yes, I checked the surface finish. It's okay. Why do I always check it? Now, please. Okay, there you are. Probably, yeah. And, well, it is there. Yep. I can push the button like that. Let's see now what kind of sound does it make. Very nice actually. More oil. This goes like into butter. And I know when it grips hard, it does. It's really hard. Let's take it back, and now I would like to adjust my tailstock in a way that it's not squeezing hard. So it's just supporting, but nothing more than that. There you are. It is there you are. Okay. Let's see where we are. Oh, long way to go still to Tipperary. It's very nice to be able to squirt the oil directly where it belongs to and not having the acid brush hanging around. I think I need to add oil. Mew, mew, mew. Man. Oh yeah. It consumed all my oil. Need to have more here. Even more. Okay. There you go. Well, the cap is airtight and it's heavy and it pushes the oil into there. Let's see now. And now we go on. Where is it? There you are. How much do we have still to go? Oh yeah, not much. I have to be careful not to damage here. I want to use the hacksaw for the rest of it because of the, let's see, mew mau. How much? It still has about 10 millimeters there, the diameter I mean, and I want to about 10. Let's put it like there. If I take 6 millimeters out of diameter, so then it should be easy to hacksaw away. There you are, no more. Exactly. Yeah. I will use my hacksaw to get rid of the rest. There is no sense in like destroying your parting tool with this, which happens really easily if you go to the end. Especially in a setup where you have the tailstock supporting, and the rubber mat is not optional here. There you are. Well, that parting tool is really nice. It's it's really nice. Doesn't make any. Well, it just cuts. And there you are. No amazing noises or anything. It just cuts. Let's see now if I can get rid of the center tab first. That one. And then get rid of that portion. Oh man, we have some cutting oil there. Swamps. Okay, now automatic feed, slow, and very fine cut like that, and of course it's feeding the wrong direction. Let's see what happens now. It doesn't sound good. Actually, it sounds really bad. Oh, what is this? Okay. Well, I think the insert is broke. Really. I'll turn it a little bit and let's see. Because this is sounds horrible. Let's see about the yeah, and the surface is well, it is. Okay, I think we don't need that. The modulation, I mean. This sounds similar. Man, what is this? Okay, better now. Okay. Yeah, it's really smooth. So now, what I want to do next is to bevel this. I forgot that. We need to bevel it because it will be welded. And it will be 45 degrees bevel. Okay, and then 45 degrees, like that. Man. Well, it has. It has. Okay, then we go. A little bit more. I think I leave it to that. There you are. It's that. Ooh. Okay, now the two final steps for this workpiece. First, facing this surface one more time, because the welding did actually warp it a little bit. Yeah, so I'm going to face it from yeah, until just until it's like straight. So I will take very faint cuts here now, something like oh, okay, I need to run it in order to get this done. Okay, so I'm running it 0.25, cutting 0.25 millimeters. Yeah, okay. Oh. Okay, now we have a surface. And then I need to do that surface as well, the outside. And this one we need a lot slower speed. And oh well, it's not always possible to choose your materials. In this case, that round plate, first of all, it was very strange material to cut. It was quite hard, and then, well, it was hard to cut. I don't know what it is actually, but well, it welds well. As you could see, there was this slot in the back side of that. I don't know why is it there, but I welded it very successfully. Now it's closed and for nobody to see it there. And well, it does not weaken this thing at all, actually. Yeah. And then threading. First of all, it was a punishment. Threading M16 thread into that material. If I had to choose a 0.5 millimeter bigger drill to make the threading a little bit easier, but it was still quite hard to do. So yeah, that was but it's done now, and it's straight, and the last cuts I made, they are not only optical. Yes, they are optical, but they also enhance the balance of that thing. It's rotating 1,500 revolutions per minute anyway. So, it should be quite well balanced, really. What else? I first of all thank you for watching this far, if you are here, and thanks for all new and all previous subscribers for the support. And then what else? The next episode. These a little bit smaller motor couplings. It will be, we are going to construct the plate, which we didn't do the last time, which is actually, on the other hand, it's connected to the standoffs, and on the other hand to the compressor. And then we put it together, and we might also test it a little bit while it's on. I have a VFD, and I can connect it temporarily into that motor, so we can test it. Maybe. Yeah. Okay. Till next time. Bye.